In this video, we are going to learn how to calculate probability. We will start with simple questions first, but before we do that, you need to know the basic formula for probability. Probability of an event is equal to number of favorable outcomes divided by total number of outcomes. Favorable outcomes are those outcomes where the concerned event happens. Total outcomes are all possible outcomes of the experiment. The questions we will now solve will make things clearer. Question 1. Abby tosses a fair coin. A. What are the possible outcomes? B. What is the probability of getting a heads? C. What is the probability of getting a tails? Before we start solving, here's a quick note. Usually in exams, the questions will have a fair or unbiased coin, die, etc. even if it is not specifically mentioned. It just means that all possible outcomes are equally likely. Just for your knowledge, when the coin or the die is biased, we use experimental probability to calculate the probability. Let's park this for later. Solution. Part A. When a coin is tossed, possible outcomes are heads and tails. We also write this as Part B. We have to find the probability of getting a heads. Total number of outcomes equal to. Since there are two possibilities of outcomes, this will be equal to 2. Number of favorable outcomes will be the number of outcomes which is heads out of all possible outcomes. From the two possible outcomes, we have only one outcome which is heads. So this will be 1. Therefore, probability of getting a heads will be total outcomes will be 2, which comes here. Number of favorable outcomes comes here. So probability will be 1 by 2. It can also be written as 0.5 or 50%. Part C. We have to find the probability of getting a tails. Total number of outcomes will be equal to 2. Since there are two possibilities of outcomes, heads and tails. Number of favorable outcomes will be the number of outcomes which is tails out of all possible outcomes. From the two possible outcomes, we have only one outcome which is tails. Therefore, probability of getting a tails is equal to 1 by 2. Question 2. Ryan rolls an unbiased die. What is the probability of getting a 3, a 6, an even number, and a number less than 5? Solution. When a die is rolled, what are the possible outcomes? They are 1, 2, 3, 4, 5 or 6. So the total number of outcomes is 6. Part A. To get the number 3, what is the favorable outcome? It is the number 3 itself out of the 6 outcomes here. So the number of favorable outcomes is equal to 1. Therefore, the probability of getting a 3 will be number of favorable outcomes, which is 1, divided by the total number of outcomes, which is 6. So 1 by 6 is the required probability. Part B. To get the number 6, the favorable outcome will be 6. So the number of favorable outcomes will be 1. Therefore, the probability of getting a 6 will be number of favorable outcomes, which is 1, divided by the total number of outcomes, which is 6. So 1 by 6 is the required probability. Part C. To get an even number, what will be the favorable outcome out of all the 6 possible outcomes? They will be 2, 4, and 6. So the number of favorable outcomes will be 3. Therefore, probability of getting an even number will be number of favorable outcomes, which is 3, divided by the total number of outcomes, which is 6. We reduce this to lowest terms by cancellation to get 1 by 2. Part D. To get a number less than 5, what will be the favorable outcomes out of all the 6 possible outcomes? They will be 1, 2, 3, and 4. So the number of favorable outcomes will be 4. Therefore, probability of getting a number less than 5 will be number of favorable outcomes, which is 4, divided by the total number of outcomes, which is 6. You reduce this to lowest terms by cancellation to get 2 by 3. Question 3. There are 10 number cards as below. One card is drawn from the pack without looking. What is the probability of drawing a card with the number 3, the number 6, an even number, and a number that is a multiple of 3? Let us first check all possible outcomes of the experiment, which in this case is drawing a card. When we draw a card from this lot, any of the 10 given cards can be picked, which means any of the 10 given numbers can show up. So, each of the 10 numbers is a possible outcome. Therefore, possible outcomes will be 6, 7, 4, 2, 9, 6, 3, 5, 6 or 1. So the number of outcomes equal to 10. Note that this is equal to the number of cards, because number of cards will be the number of options or possibilities. The number of outcomes will remain the same while calculating the probability in each question part. For part A, the event is getting a card with number 3. Number of favorable outcomes will be, how many cards have the number 3 written on them? Just 1. So the number of favorable outcomes will be 1, since there is only one card, number 3. Therefore, probability of getting a card with number 3 will be equal to number of favorable outcomes, which is 1, divided by the total number of outcomes, which is 10. So the required probability will be 1 by 10. Part B. The event is getting a card with number 6. Number of favorable outcomes will be, now how many cards have the number 6 written on them? We see that there are 3 cards with number 6. So the number of favorable outcomes will be 3, since there are 3 cards with number 6. Therefore, probability of getting a card with number 6 will be equal to number of favorable outcomes, which is 3, divided by the total number of outcomes, which is 10. So the required probability will be 3 by 10. Part C. The event in this case is getting a card with an even number. How many cards have an even number on them? There are 5 such cards. So the number of favorable outcomes will be 5, since there are 5 cards with an even number. Therefore, probability of getting a card with an even number will be equal to number of favorable outcomes, which is 5, divided by the total number of outcomes, which is 10. So the required probability will be 5 divided by 10, which when reduced to lowest terms gives 1 by 2. Part D. The event in this case is getting a card with a number that is a multiple of 3. How many cards have a multiple of 3 on them? We see that we have the cards with numbers 6, 9, 6, 3 and 6 as circled in black. So there are 5 such cards. Therefore, the number of favorable outcomes will be 5, since there are 5 cards with a multiple of 3. Therefore, probability of getting a card with a multiple of 3 will be equal to number of favorable outcomes, which is 5, divided by the total number of outcomes, which is 10. So, the required probability will be 5 by 10, which when reduced to lowest terms gives 1 by 2. Question 4. The letters of the word probability are written on separate cards. These cards are kept face down. One card is picked. What is the probability of picking a card with P, B, a letter in the word maths? Let's again find the total number of outcomes first. How many letters are there in the word probability? There are 11 letters. So the total number of outcomes will also be equal to 11. Part A. The event is picking a card with letter P. How many cards are there with the letter P? Just 1. So number of favorable outcomes will be 1. Therefore, the required probability will be 1 divided by 11, which is 1 by 11. Part B. The event in this case is picking a card with letter B. There are 2 cards with the letter B. So the number of favorable outcomes will be 2. and the required probability will be 2 by 11. Part C. The event here is drawing a letter in the word maths. We will now check for each letter in the word maths one by one in the word probability. How many M's are there in the word probability? 0. How many A's are there in the word probability? 1. How many T's are there in the word probability? 1. How many H's are there in the word probability? 0. How many S's are there in the word probability? Again 0. So total favorable outcomes will be equal to 1 plus 1. 1 for the A and 1 for the T, which is equal to 2. Therefore, required probability will be equal to 2 by 11. That's it for this video. Make sure you watch this video again and practice questions from your textbook. You can ask your doubts in the comment section of the video. In the next video, I'm going to take up slightly more difficult questions. Difficult only if you do not study. Otherwise, it's all easy. See you soon.